Now let's coming to the part one, statistical characteristics and complaint data. Question number one. That is, give a three commonly used statistical measures to characterize dispersion and complaint derived scores. Discuss how these measures can be computed efficiently over large complaint repositories. So we have to discuss three statistical methods which characterize dispersion in complaint scores. So what is basically dispersion starting off? Dispersion means how complex or spread out a complaint is. It highlights the difference in offense severity, evidence strength, or harm index. Like how severe basically a complaint is being referred is known as dispersion. Methods of dispersion. So first is range. Range is high value to low value. High value minus low value is considered as range. Like total spread of data could be ranging from 2 to 9. So range would be 7 as 9 minus 2 is 7. Then we measure it by variance, that is denoted by S square. Average of square difference from mean. This would be the formula where S square is variance. Summation of n. N is total number of data points. Then xi would be individual value of data, and x ki power, sorry, not x ki power, x median is average of data points. So we will apply this formula to calculate variance. Then standard deviation. Standard deviation is directly related to variance and it has formula of s whole root square. Like it could be also written as this. Standard deviation can be written as this. That is equals to whole root square, whole root s square. Now, computation for large repositories. अगर हमारे पास बड़ी repositories हैं तो how do we compute the issues and problems? So in real life problem, data is huge in standard of millions and billions. अगर हम रियल लाइफ प्रॉब्लम देखें तो उसमें जो डेटा होगा वो particularly in numbers of millions and billions होगा, which is stored in servers. So big data techniques that takes the data from DSS system or how the data is being partitioned or applied. So first is partition stage. That is data split into partitions. हम क्या करते हैं? हम data को simply split कर देते हैं in partitions to make it small and then work on those partitions. ठीक है, फॉर डिस्पर्जन सच पार्टीशन कंप्यूट लोकल स्टैट्स. ठीक है, अब डिस्पर्जन में हम इसके जो हमने फॉर्मूलेज देखा दैट इज ऑफ वेरिएंस, रेंज एंड काउंट, वो हम हर पर्टिकुलर पार्टीशन करेंगे. लाइक ये हमारे पास एक पूरा होल वैल्यू, होल डेटा था जिसको मैंने छोटे छोटे पार्टीशंस में डिस्ट्रीब्यूट कर दिया. एंड नाउ वी विल सी एस, वी and all those values for these small partitions. तो इसके लिए S1 हो जाएगा, ये V1 हो जाएगा, यहाँ पे वही चीज S2 हो जाएगी और V2 हो जाएगी. ठीक है. नाउ पैरेलल प्रोसेसिंग इज फास्टर. इसके अंदर जो होता है बेसिकली पैरेलल प्रोसेसिंग का कंसेप्ट जो होता है वो फास्टर होता है. नाउ streaming aggregation, that is it is an online algorithm when complaints are non-stop and continuous. Here stats are updated one complaint at a time without storing all past data. Streaming aggregations कब होता है? जब हमारे पास complaints जो है वो बहुत ही non-stop and continuous है और यहाँ पे stats जो है वो update होते हैं. ठीक है. We use Welford's algorithm and mean and variance to find. हम streaming regression में mean and variance. तो partition में हमने partition किया, streaming में हमने algorithm apply की है जहाँ पे एक के बाद एक हम पहले एक देखा, फिर दूसरा देखा, फिर तीसरा देखा, ऐसे करके एक के बाद एक complaints देखते जा रहे हैं. ठीक है. Then approximation sketches, that is for large data sets. Most common techniques use the T-digest approximation, good for parentiles and SG, count minimum sketch, fast frequency estimation and hyperlog. तो हम इसमें ये सारी डेटास अप्लाई करते हैं. This was the first question for part 1 internal 1.